Hello, good day. This is Jimmy Akimbade. So today we'll be looking at failure modes and effects analysis. Failure modes and effects analysis is a tool used in Six Sigma and in other areas. It's used for identifying how a product, process, system, or design can fail. We want to know how a particular product, process, system, or design can fail so that we can either prevent the failure or mitigate its negative impacts. So it's a way of being more proactive. We want to identify ways in which a product, process, system, or design can fail even before the failure occurs. So it is used when designing a new product, system, or process. So we can use it to identify how a new product, system, or process can fail. So, for example, um, imagine the time that the first touch screen phone was developed. One of the things they could have done is to identify how it can feel since it wouldn't have the physical keypad. It's also used when changing an existing process, system, or product. So, for example, if you want to make the transition from using knife to cut meat in a butcher shop to using an automatic meat cutter. So what can go wrong? Um, of course, one of the things that can go wrong is if somebody's finger gets in contact with the automatic meat cutter, the person's finger can be chopped up. Then we also use it when using an existing design in a new way. So it's used in the define phase of your Lean Six Sigma project to understand the project risks, what can go wrong in developing a new product, system, or design, and how we can mitigate or avoid such risks. It's also used in the measure phase to assess how key inputs influence risk. So what that means is if we want to make a change in a particular component of a product, what negative impact will it have on another component of the product or the performance of the product? So, for example, if we want to ensure that the battery of a smartphone charges fast, can it have any negative impact on other components of the phone? It's also used in analyze space to understand the risk of improvement implementation. So, what can go wrong if we want to make improvements, just as we said before, if we want to increase the rate at which the battery of a smartphone charges, what can go wrong? What could be the negative impact? Can it make the phone to usually get hot? What could be the negative impact? We also use it in improve phase to evaluate the effectiveness of the control plan. So what that means is after we develop our after we conduct the failure modes and effect analysis, we can also use it to come up with mitigation strategies. After implementing the mitigation strategies, we can reconduct the failure modes and effect analysis to ensure that the probability of risk occurring has reduced or that we have better controls in place to mitigate the negative impact of a failure. So we have different types of failure modes and effect analysis. The first one is design FMEA. So this is used when we are analyzing the design of a new system, process, or product. So just as we said, the first touchscreen phone, noting that it won't have a physical keypad, what can go wrong in the process of using such type of smartphone? Then we also use it. It will also have the process FMEA. You can use this to analyze the steps of a particular process, what can go wrong, what are the impacts of failure. So this could be used in construction project, for example, to conduct what we call job hazard analysis, whereby we can pick up a particular job to be done on the construction site, break it down into steps. For each step, we identify what can go wrong, what are the hazards, and come up with a mitigation strategy. So, for example, if you would have people that will be working from at a high height in a construction project, you already know that one of the risks is falling from a high height. So, what do we do? Do we have a fall arrest system to mitigate the negative impact of falling from a high height? Then we have system FMEA. This looks at how a particular system can fail and how the components of such system can fail. What can go wrong in a particular system? How can we prevent the components of that system from failing? Then we have product FMEA. This looks at a particular product, how the components of that product can fail, how the functions of a particular product can fail. So we'll be looking at a laptop as a product. What are the components that can fail? The screen, the mouse, even the operating system. So those are the different types of FMEA. So how do we do it? First of all, identify the product, service, or system you are going to analyze. Just as we said before, it could be a smartphone, it could be a laptop, it could be a particular process working at a high height in a construction project, for example. Break it down into the steps or components. Identify how each step, component of that product or system can fail. Then list the potential impact of each failure mode. If it fails, is it that it would have a negative impact like a life or death situation? Somebody will be injured, for example, from falling from a high height. Or is that if it fails, uh, it would have a negative impact on the customer? So, for example, if you have, if there was a uh, mistake with the touchscreen phone, is it that instead of calling somebody, it makes the mistake of calling somebody else? So assign ratings for each, uh, assign ratings for the severity, the level of impact, and the occurrence. So if probability of a failure occurring is high, we can assign it a 10. If probability of the failure occurring is low, we can assign it a 1. If the impact would be life or death situation, of course, that would warrant a 10. If the impact would be that it's negative but it is mild, customer will still be willing to work with you or use the product in the future. The impact rating could be 1. Then also list current monitoring and controls for each failure mode. So what that means is sometimes we may not be able to prevent a failure from occurring, but we can mitigate negative impacts. So that means you can have a detection mechanism such that even though the failure occurs, before the customer experiences the negative impact of the failure, would have mitigated the negative impacts. So, for example, a system like WhatsApp or Facebook, since it's meant to be used all over the world, it would have multiple servers. So, when one server is down, they automatically switch over to another server, but the customer will never notice. So, even though the failure has occurred, it has been successfully mitigated. So assign a detection rating for each monitoring and control mechanism. So for that example, just look at, since they have a an automatic server that backup that they switch over to, detection rating there will be a 1. Yes, it will be a 1. But if there was no way, if the damage would have already been done, the failure would have occurred, we wouldn't have known about it. The customer now calls us to tell us about the failure and the negative impact on him or her, the detection rating there will be 10. So the lower the detection rating, the lower the numerical value, the better for you. The higher, the worse for the organization. So calculate the risk priority number for each failure mode by multiplying the occurrence, probability, impact, severity, impact of severity and detection together. So if probability, for example, of one server going down is 4 and severity is, let's say, 3, and then detection is 1, that means 4 times 3 times 1, that will be 12. So use the RPNs to select and work on the high priority failure mode. So that means a failure mode having an RPN of 125, for example, 5 times 5 times 5, would carry more weight or more priority than another failure mode with a RPN of 12. So the higher the RPN, the more priority that should be given to the failure mode. Implement and document the plans to reduce or eliminate the high priority failure modes. So the high priority failure mode should be your major priority to ensure that the RPNs are reduced by either ensuring you have detection mechanism in place, reducing the impact or reducing the probability of the failure occurring. Then recalculate the RPNs. So recalculating the RPNs ensures that you confirm the effectiveness of your plan to either avoid the failure or mitigate it. So ratings, severity of failure could be from 1 to 10, 10 representing the most severe impact on customers or other stakeholders. Probability of occurrence of failure could be from 1 to 10, with 10 representing the most likely to occur, something that would occur sooner or later. Detection of failure is also from 1 to 10, with 10 representing least likely to be noticed with the present control methods. You could also use 1 to 5. So in this case, 5 for severity would be the highest impact, 5 for probability would be most likely to occur, then 5 for detection would be the failure would have occurred, customer or stakeholder would have experienced negative impacts. So that is the failure modes and effects analysis. Hope you learned one or two things you can apply to your project or work. Have a great week. Bye.